Every year, agriculture plays a major role in our greenhouse gas emission. While it sustains food production and feeds billions, the way we grow crops, rear livestock, manage soil and land also release significant amount of heat-trapping gases into the atmosphere. What are greenhouse gases? CO2, CH4, N2O.
Methane CH4, especially from ruminants, livestock like cattle, sheep, etc., from their enteric fermentation, also from manure management and rice pad. Nitrous oxide N2O, primarily from soil when fertilizers are applied from crop residues. This gas has a much stronger warming effect. Carbon dioxide CO2 comes from fuel use like from tractors, farm machines, etc. Next, input manufacturing like fertilizer, pesticide, etc.
Agriculture contribution to global greenhouse gas emission. First, globally, agri-food system, which includes crop and livestock production, land use chains and supply chain, account for about 1/3 of total human caused greenhouse gas emission. Second, in the United States, the agriculture sector, just farming operation, constituted about 10.6% of total US greenhouse gas emission in 2021. Third, specific to crop and livestock production, excluding from indirect emission, agriculture contributes around 10% of US emission. What are the main sources within agriculture? First, cattle and other ruminants emits methane through enteric fermentation. Second, manure management, storage and treatment of animal waste produce CH4 and N2O. Rice cultivation and flooding. In flooded rice paddies, anaerobic condition leads to methane release. Soil and fertilizer management. Application of nitrogen fertilizer and crop residues leads to N2O emission, and soil can also release CO2 when distributed. Land use change. Deforestation, draining pit soils. When natural ecosystem are converted to agriculture, large CO2 release happens. Why does this matter? Impacts. Rising temperature, erratic rainfall, droughts and floods threaten crop yield and livestock productivity. Agriculture own emission versus the climate risk, creating a feedback loop. For consumer, higher emission means more risk of price, supply disruption and environmental degradation. In food system, keep growing emission unchecked, it will be harder to meet global climate target. What can be done? Solutions and mitigation. Technology and behavior change. Use precision agriculture, reduce only meats diet, reduce food waste, improve soil and crop management. Less tillage, cover crop rotation, improved nitrogen use efficiency, reduce N2O and CO2 losses. Livestock improvements. Better feeding, breeding, manure management, methane capture technology for manure storage. Land use management and tree cover. Prevents deforestation, restore pit lands, adapt agroforestry to sequester CO2. Land use management and tree cover. Prevents deforestation, restore pit lands, adapt agroforestry to sequester CO2. Policy and financial incentives. Support farmers in adopting low emission practice, invest in research and create market that reward climate smart agriculture. What this mean for India or local relevance? India has large area under rice cultivation, significant livestock number. Both high emission practice. Innovation in India. Alternate wetting and drying in rice, better manure practice and agroforestry. By adopting climate smart practice, India can maintain food security, improve farm income and reduce vulnerability to climate change.
Conclusion and call to action. advocate for climate-smart farming and policies, reduce food waste, support sustainable agriculture practices, choose diversified and lower emission diets, because when farms become climate solutions, everybody wins: the planet, the farmers, the food on our plates.